Okay, thank you very much. It's a great pleasure and honor to be with you today. It was due to Steinar and Johan action. They invited me. Thank you one more time for that. So I can spend today in Sweden presenting SQL Server information about weights. In the morning presentation in Malmö, I just told that I tell all about weights. And I then figure out that it's not possible during 90 minutes. That's why you can see the star here. It's all important you should know about weights. Otherwise, we have to spend here all the week, which could be great, but I don't know if the Microsoft is happy to have us till Friday. So my name is Damian Widera. I come from Poland, in the south, from south of Poland, from the city, quite big city, which is called Katowice. It is a central Silesia region. And what I'm doing, I'm working for LGBS software company, which is now kind of big one. We have even a project in Sweden with Swedbank, and we do the project in Poland. What I do for them, I am project manager and technical lead, and also doing what I really do. So I'm doing SQL Server stuff also. So not only managing, so doing nothing, but also doing actual job, actual work, I mean SQL Server stuff. I'm Microsoft certified trainer and MVP, and also I wrote a book with two of my colleagues, which is a great book, but I don't think you can take it. So you can, but it's in Polish. So 435 pages of great content. However, it's not easy to read in Polish. So I think it's in Swedish could be that hard as it is in Polish. If you would like to send me some information, you can ping me on Twitter, on Facebook if you wish. There is my private email and also a blog where I occasionally try to put some articles. The presentation as well as the code will be available on SkyDrive. I also talked to Johan that I sent him the presentation, the code right after the meeting today, so you can download it probably tomorrow. He will publish everything. So the topic of this meeting is, why is the server waiting? Because if a server is waiting, somebody is complaining. Yes. So this is straight, relationship. If the server is waiting, somebody is complaining. So those are actually responses from my customers for the question. So the server is waiting because it's slower. It runs slower than previously. So this sentence is very hard to understand because there is you cannot measure what does it mean previously and what does it mean slower. You have no measure. You cannot say, is this okay or is it actually wrong? You have to do something with this. I don't like talking with my client on that level. Yes, we have to have some measures. And I would like to show you how to do this during this talk. Then everything is slow, and this must be a database problem. Very frequent complaining from the customers. You created a database, it's slow, so it must be a database problem, not the application. I hope you can see such problems also in Sweden. And the last thing, which is the most common in Poland, we have not changed anything on the server. It was just running. It's actually a very big problem because that means that no one cares what's going on with the server. It's just running. Okay. So where would you like to start if something is very, very slow? You have some complaints, you got some phone calls, someone is complaining. So where would you like to start the diagnosis? You can talk to me, of course. So, okay, because we have only 90 minutes. So we can start on hardware level. We can start on I/O. Inspecting I/O. We can inspect indices or indexes. I don't know which form is correct in English. I believe indexes, but indices probably too. So I was not sure, so I put both. And what can we do? We can inspect the application. However, imagine that we have also care about virtualization. Sorry for this Polish. It means virtualization. 10 years ago, when I started my journey with SQL Server, 10 or maybe 14, I just can't remember, we have solid box. It was called a server, yes? Everyone knows where it is. So it was running, it was hot, it was noisy, so everybody knows that this is the server. And when we try to inspect, we know that we should check the hardware, the operating system, which means Windows. We have to check the SQL Server configuration, and then we can drill down up to table, indexes, and query level. However, in current world, we have also the virtualization layer, which makes all the diagnostic way more complicated, as you may imagine. So we have to take a look also on the hypervisor and everything else which is connected to the virtualization. So where would you start? How would you start investigating the problem? We can ask SQL Server, because SQL Server can give us pretty much information, like weight statistics. We will be examining weight statistics pretty much. Dynamic management view, of course. Performance monitor. I believe you do it all the time. You have to monitor, yes? And at the end, we can analyze query plans. There is also one special thing which is called weights and queues methodology, which help us in tuning. There is a great white paper. I will be calling it every time during the demos. The white paper was written by Tony Davidson in the years 2006. And believe me or not, it is still valid. We can still use it. It's a great example how to tune our SQL Server. But the problem, even if we use all those methodologies and tools, we have a problem how to interpret the data, I believe. So, 3 people come to a doctor. There is a mistake, but leave it as it is. All of them, there will be 3 people. I will be the second, but there will be 3 people. All of them has problems with a knee. You know what a knee is, yes? It's some part of the leg. So the first person tells that the knee hurts. The doctor gives medicine and keeps asking, is the knee the only problem? Maybe there is something else. And the person tells that, actually, I had an accident while I was skating. So I twisted my ankle. And the knee is only the result, because now I can step on the second leg. So I have to jump only on the other. So there is a problem with knee, but the original problem is the twisted ankle. The second person, as I told you, it would be me, come to a doctor and tell that there is a problem with the knee. However, the problem is because I am a little bit overweight, and yesterday I was working hard on the gym, and I have pain everywhere, and also in the knee. So there is also a problem with the knee. And the last person comes to the doctor with the knee because it's a problem with the knee. How is it connected to SQL Server? It's not medical lecture, it's SQL Server lecture. We have 3 results we can observe. However, every of those results has different origin. So we cannot just go and take a result and tries to fix the result. We have to go deep down and try to find out where the problem is. I hope that this is a pretty good explanation of this problem. Okay, what is a weight type? Following Bob Ward. Probably you know Bob Ward. Yes, SQL Server, escalation engineer, primary architect, probably the smartest guy in, he can tell you everything about the internals. This is a slide, I have the permission to show it to you. So Bob told us that the weights and weight types were originally created by SQL Server's developers to help them to resolve any bottlenecks. No, not us as DBAs, but them. However, they started to work on the weight types when SQL Server was in that version. Probably this is 6.5, I don't know. I was not active then when this server was in production. So at that moment of time, they had only logs. They have I/O, I mean I/O subsystem and network. And doesn't care and didn't care about anything else. But after amount of time, we are now in the year 2014, we have to take care. In 2014, we have 771 weight types. Do we have to care about all of them? No, probably not. I will show you what's interesting and what you should forget, or maybe what you should forget in the first place. In 2008, we have 485 such weight types. So those weight types are divided into groups. So for example, we have resource weight types, which are I/O, network, thread, memory. Yes, we have synchronization, locks, latches. Do you know what locks, latches are? Yes, I will try to tell briefly about this. We have yields and sleeps. We have external, so I mean preemptive weight types, and of course a queue. So, data interpretation. Could anyone tell me what is the problem with the server if you can see something like this? Can you guess? I don't know. Probably you should also tell that I don't know. Because this is only a snapshot of all weight types we have in the server. Oh, let's say it's sorted by one of those columns, probably wait time millisecond. It's done before the demo, so it's not real production server. I was trying to demo async network I/O, and this is the snapshot. So based on this snapshot, we cannot say what's wrong. But this is typical situation when you come to your customer. I can see it like that. We have no historical measures, and we can see only something like this. So it's very hard to say what's wrong actually. And then we have to take the responsibility and try to find out. So before we start, I would like to show you something about the SQL Server Execution Model. I believe you know it very well, but it's just a reminder, because for the reminding part of the talk, we will be using some terms that are visible here. So if you are a SQL server and you were asked to run a query, let's say select star from a table, you try to run the query on the processor. However, it may happen that you need some resource, for example, a lock or a latch, or you need to load data from the disk, and you do not have this resource available. So you will be put on this waiter list. This waiter list is just a list without any particular order. It's an ordered list. So you will be placed here, and you will be moved to the runnable queue once your resource is available. Do you know how big this list can be? No, I don't know too. That big as it is only necessary, let's say it that way. So if you have your resource, you can be put to the runnable queue. Runnable queue means that I have a task, I have all resources, I'm waiting for the processor. So this list is ordered. So when you are moved from the waiter list, you are going to the down to the last position, and it's almost true. It's one situation where it's not true. I will tell you about it. Or maybe we can do some quiz. Maybe you know what is the only one exception here. And if it is your turn, so the processor is free, the first element is popping up and working at doing its task on the processor. So it's very simple approach to the SQL Server Execution Model. And now, with all those elements, we have task state. For example, the task is suspended if it is placed on the waiter list, and we can examine it, and we can find it by examining the DMOS waiting tasks dynamic management view. If you are put to the runnable queue, you can find your status in DM exec requests. So that means that I have resource, I'm waiting for the processor. My state is runnable. And state which is running means that task is actually running, is on the processor. So its work is actually, the work is in progress. And also you can find information about the task and in the DM exec request. It was one processor. If you have them more, you can see this structure that is placed around SQL Server. You can query DMOS schedulers to see how many processors, logical processors are working, and all those structures are placed inside SQL Server. That's actually great because we can run our query in parallel. So that's what we would like to see. How is it look in practice? Actually, this is screen from this white paper I mentioned, SQL Server 2005 Weight and Queues by Tony Davidson. You should read it if you have not any chance to do it before. But let's check what's going on here. This is waiter list. So it's not ordered in any way. Every session has some information, what it needs, what resource. There is one purpose of this list. The question is, why should we put information about what is needed on a special list? We have to do this because the information about the resource, the type of the resource, we can have another session with the same type of resource, and even they need the access to the same resource, I mean the page, to the same row. So we have to have ability to differentiate them. Yes, so we have to put them on the list. We know where they are then. So right now in our processor we have one session running. At this moment of time we have some sessions that are on the waiter list and 5 sessions that are waiting for the processor. So let's do something like this. This session which was running needs access to a disk. As the disk is not available, the session is put on the waiter list. On the waiter list, the first element from the runnable queue is put to the processor and it can run. It can run. However, in the meanwhile, one of the resources is being granted to the session, let's say 56, this is CX packet, and this session is going down at the bottom of the runnable queue. There are three special cases. In that case, the first one is resource governor. This is the only case when you can mix how this queue will behave, because you have priorities, etc. I will explain it in a second. The second thing is no-lock. Do you think that if we are running query using no-lock hint, do we need any resources? Can we block something? I will show you demo. Yes, for sure, yes. And there is a special case that when only one task is running on the processor and there is nothing else. So there is nothing else in the runnable queue, and there might be nothing else in the waiter list. This is special case also. So first, resource governor. Do you know resource governor? You can create multiple workload groups and put them to the same, let's say, resource pool workload. It's like a connection resource. We have memory and CPU limits. Yes, that's obvious. So within the resource pool, if we have two, let's say, workload group, each of them can have different priority, let's say high, medium, and low. And you know that there is a ratio between them, or among them. So high means 9, medium means 3, and low means 1. This is the priorities. So how it is connected to the runnable queue? For one thread of low priority on the runnable queue, 9 high priority threads will be allowed to run first. So if you have a low priority thread on the top, and suddenly something is coming out from the waiter list which has higher priority, it will be put on top of the low. Why do we care that one thread of low priority must run per 9 of high priority? How do you think? It's very important because imagine that we have one workload group which has high priority and one group which is low priority. If the ratio will not be maintained, I mean 9 to 1, then the low priority threads will never get to the processor because high priority will will pop up again and again. So we have the limit that 9 high priority, then low priority, again 9 high priority tasks. This is important. So it was the question, the quiz question. Okay, no lock. What in that case do we need to wait for anything during no lock? Sure, sure. I/O latches, for example, yes. Have you used trace flag 1200 before? This is a great trace flag that helps understanding how the locking actually works in SQL Server. So I have a very quick demo about this. So I will show it to you. I have to remember that I have to switch the to duplicate the monitor to duplicate. Okay, Management Studio. Can you see this? Probably. Okay, I do drop clean buffers. I don't want to have situation like in Malmo that this demo failed because everything was in buffer. So I start the trace flag 1200 and 3604. 3604 actually print the information to the console. Okay, so let's see if they are started. Should be, yes, I have a bunch of other trace flags from previous demo about deadlocks and using new optimizer. So, but we can leave it as there is. Let's start this query. Top 10 information from sales reason. We have the information, and there is information about logs. All logs that were done with this query. So it's a great, learning experience because you can see what SQL Server does, what SQL Server is doing when you are trying to get data. We're starting from setting the S-lock, shared lock on the database because we have to inform that we are connected, yes? So somebody else is not allowed to set exclusive lock on this database. So where is the actual lock? See, this is on object. Probably those are informations needed to get the data, and we are releasing the lock on the database, and we have some metadata information also, lock on metadata. So probably latches too, because we have to load the data from the disk. This is global trace flag. So imagine that you run it on production. Don't do this, yes, because you will be flooded with messages. And the server will really have a problem, performance problem, in a moment. Oh, there are uncommitted transactions. No. Okay. So it was only a very short and quick demo. But there is also a third special case when there is only one task running on the processor, and let's say that the runnable queue and waiter list is empty. How long this task is allowed to run on the processor? It has to load 10 million rows. How long can the task be running here? Only 4 milliseconds. After this 4 milliseconds, it has to go back to the runnable queue and go back to the processor. This is called quantum. This is hard-coded quantum, which is 4 milliseconds. And this switch back to the runnable queue is you can find this. And if you query the wait stats, and you will find SOS scheduler yield. This is very important because if one task will be running on the processor, nothing else will be able to run. You have to, let's say, voluntarily stop the task here, move it to the runnable queue, and run it again. And it must go that way. So we can see SOS scheduler yield in many times during this my presentation. So I will point it that you will see this. Okay, it was the third special case. Where do you find wait type? Historical statistics in DMOS wait stats. Live data in DM exec request, and of course DMOS waiting task. The old sys processes is the legacy view, so don't go there. Extended events. Do you use extended events? Yes, pretty much, or all the time. So I have one demo that I will present how to get data only from one particular query. I mean all the logs you can have. This is important because almost in any other cases, when analyzing this and this, you will have data that are accumulated, especially in this historical stats. So you don't know what was done in this particular connection. Extended event can help us. There are also some other tools like management data warehouse. Of course, what else? Activity monitor, yes. Performance monitor counters. Activity monitor is great. However, it stops working when you really need it. If there is a problem with server, activity monitor stops working. So you know that there is really a problem because it can't refresh the views. Okay. This is the first and most important view. When you are actually with your customer and you are asked that there is something wrong, you have been told that there is something wrong with the server, you have to go and check DMOS waiting tasks. Because in this view, you will see what is the server waiting for now at this particular moment. However, to have the better situation and better view, you have to join the DMV with other data management views, like exec sessions, like exec request, for example, then SQL text, and if we have SQL text, we should have SQL plans also. Okay, short demo about this. Where is waiting tasks? Okay, if I run you can't see, you have to tell me that nothing is displayed because I run the query, I will explain it and okay, now you can see. What is the system waiting for right now at this moment? We have many waits. Should we care about all of those? Look at this session ID. This is session ID. The session ID is, let's say it's not user connection. Previously it was a guideline that user session is always greater than 50. It's not anymore. So I will show you what to do to display only really user connection. There are some internal, let's say, waits that are important for SQL Server, but not important for us. We should always throw them away from any analysis. In very, very rare situation, you might be forced to analyze some of them, but so far I have not any chance to do this. So maybe it's really not important. What we have? We have session ID. This is important. We have wait duration in milliseconds. So if we divide it by 1,000, we have duration in seconds. We have wait type, actual wait type, and what is also important here, we have blocking session ID. So if we have really a blocking problem that the task is blocked by another one, we can find the information here. So I start a simple query, very simple query. I have to create a database. I call the database SQLug. It is very simple database with very simple table inside. Only one table. The table has one column, which is identity and primary key and clustered index on the table. I have to turn off that's what I told you, that it should be turned off. Okay. The database, okay, I do it one more time, cannot drop because it's currently in use. So everything is fine. So now I start 20 connection to my server, and within the connection, what I do a pretty simple thing. Every of those connections will do insert default value to this simple table in my SQLug database. So you can imagine that there might be some contention. There are 20 clients running. So let's examine this if we can see some other things. No. Nothing. So if nothing, that means that something went wrong actually. So I have to rerun the demo one more time. So I will drop the database. I set it one more time, db create. Okay. Now it should work. So let's start it one more time. Now it's okay. And let's check the view one more time. That's better. You see page large. You see the session is greater than 50. So it's almost always true that user session is greater than that. You have page latches. So this is actually information that some page is blocked. And I can refresh. And every time I refresh, you can see that this view has changed. What can we do? I found a query which was prepared by probably Paul Randall or Glenn Berry, which can help us in analyzing OS waiting tasks. You have to join, as I show in the slide, to the exec session, because then on the exec session you have CPU time, you have memory usage, you have program name, then we have join to exec request. From exec request, we can try to find % complete of each query. It's not running all the time perfectly, but sometimes you have meaningful value there. And then we can go to join to SQL text. In SQL text, what we have the text of the query, and SQL and exec query plan gives us the plan. So we can run it. And this is the filter which shows us only the user process. So in DM exec session, you have column which is called is user process. If you set it to 1, you have really information about the session that are user sessions. So you see that we have write log, wait type, and page large exclusive on the same resource, which is of course for the for the exclusive large page large. It must be that way. The application name is called SQL CMD. This is the query text. This is the query text, and this is the query plan. So imagine that you are trying to find out what's wrong with the server, and you are opening the plan, and you can identify that last time when you compiled the query, the plan was different, and right now it has changed. So something is wrong. I don't know if it is wrong. Maybe statistics are updated, or maybe not. And you can see if the plan is correct or not. At least you can see the query which is actually running. So this is waiting tasks. I will stop the client connection. At what time do we have the break? Because I don't want to talk too much.
About 10 minutes.
10 minutes, okay. So we have to really speed up. Waiting tasks. Please remember waiting task. This is actual waiting information. Wait starts, probably you know the view. This is, I use it pretty much to see the trends. Of course, if I have the history, I can see the trends. Basically, and most of the time we don't have the historical analysis. But if you would like to set it up, this is the procedure. This is my procedure, but I believe you can do it the same or even better. So I store the information from the OS wait stats plus get date. So I have information when the task waited. I store all those information in a table, and I have two SQL agent job. One which is after every minute, I don't know, 15 minutes, half an hour, maybe every hour, do the snapshot for me, store the information in a table, and I have second SQL Server agent job that can clear or archive all snapshots. And then after a time, I can do some analysis. So I know what probably could be wrong, but there is also a problem that the server might be running for a longer time, and you can see some top weights. However, they are not really relevant at this moment because they are old. So what we have to do, we have to clear the dynamic management view. The first approach is not very convenient, yes, because we don't like to restart our production server. It's mostly not possible. However, you can clear only the view by using dbcc SQL perf, state the view name and then the command clear, and the view will be clear out. So it's the most safe way. So if I was starting the analysis, I would do this for the first time because I would like to have the clear background and then try to save the snapshots. So how it looks like, very quick demo to wait stats, duplicate, weights. This is clear. This is refreshing all dynamic management views, yes, but try not to do this. Shut down with no wait does what it states, yes. It shut down, no waiting for anything. So it's a pretty dangerous query. So if we clear the view that way, we can check what are actually information from the SQL Server. What is the SQL Server waiting? Pretty much for nothing. There are some tasks, let's say lazy writer, sleep, which is not a view itself. It counts the view, it counts the wait time when it does nothing. So when it sleeps, it counts. Well, it's opposite to view. It's a readiness state, let's call it that way. So if I run the 20 connection one more time to the server, we can check in a moment if we can see something interesting in this view. Transaction was deadlock. So I haven't seen something like this before because it's in use well. So let's drop it that way. Probably some open transaction is running, so I'm trying to find out. Well, okay, we can try to examine by activity monitor what is going on. What are we waiting for? See how smart I am? I have found the problem, so I can kill the process. Let's see if it help. If it help really. So alter database, use master. Okay, now we should have it. So use master here too, or it's better to close it. Weights, use master. Maybe now it will be okay. It will be easier. db create. Yes. So we found the problem. Now I can run my query. So 20, but first I'd like to clear the view one more time and try to run the query. So 20 connections that are running. And we can try to find a problem here, but it's not convenient. I can see that there is a page latch, also shared latch, and some other things, but you cannot read anything from there. No one can, or no one could. So there is also a pretty nice query that can analyze the view, throwing out all those wait stats that are not necessary. You don't have to look at them. And this query will display information of those types, wait types that accumulates to 95% or display 5 rows. So that was done by Glenn Berry for sure, and this is my invention. Why I did it? Because sometimes I have situation that only one wait type was on the list. It took more than 95% of everything. However, it was not relevant. So I put this, and this ensures me that I have at least 5 rows in this view. So right now I can see that the write log is 58%, 39, 40% is page large AX, page large shared and latches also. What are the times? Signal time, so this one, is how much time do you spend on the runnable queue. Wait in seconds, resource time is how much time have you spent on the waiter list, yes, and this is total waiting time. Should I care about this, what I see? This is the question before the break. You don't go to break if you tell me if there is a problem on the server or not. We have cleared the statistics. We are running something. Please tell me if the server has a problem or not.
You need to split your data and load on different drives.
Yes, but yes, sure, because I have only one drive. Yes, write log tells me that there might be a problem, especially that one. But look here, average wait time is this is milliseconds. So if one was here, it would be 1 millisecond. So I have 0.2 of milliseconds everywhere, almost. So in that case, I don't care. The server is running, especially during the demo. Why it is running? Because I'm not doing anything else, yes? If there will be a concurrent connection, it will not be that nice. We would have pretty much any other wait tape also here. Okay, so let's do a short break. After the break, I will show you the extended events, and we go really deep dive into the specific wait types, so I will show you how to deal with them.